All right, we are going to look at section 13, which has to do with algebraic terminology. So in this section, we need terminology in math to clarify the objects we're working with and the difference that exists between those objects. While some differences seem slight, they can have a large impact. And understanding the subtleties can make many procedures in arithmetic and algebra easier and help us to know whether a shortcut is valid or not. So whether we can actually perform a shortcut or not. So to start out, here are a few definitions that you need to know. These are quite important, so make sure that you kind of point these out to yourself. The first one is algebra is a branch of math in which variables are used to represent numbers and numeric operations are generalized. The next one is a constant is a value that doesn't change, so it is going to be a specific number. So for example, a constant would be 5 or 0 or 3 or 1,000. A term is a constant or a variable, or the product or quotient of constants and or variables. So it can be quite a few things. So I'm going to actually clarify with this first one for a constant. A constant might be something like 5 or 7 or 983. For a term, it can be something simple like 5 or 5x or just the variable y or something like x over 3. Because this one is a constant, this one is a variable, this one is a constant and a variable, a quotient, or sorry, a product of them. Product means to multiply, and a quotient means to divide. So these are all terms. So it says, for example, 5m and 5m are all terms. Another one would be 5 over m. That would also be. If a term consists of only a number, it is known as a constant term. In the term 5m, the 5 and the m are being multiplied, which makes them factors of 5m. Since the 5 is the numeric factor of the term, it is known as the coefficient. So, things that multiply together to give you a term are factors. So, 5y would have the factors. The factors that multiply together to give you that would be 5 and y. The coefficient is what leads a term like that, and so the coefficient there would be 5. An expression is a mathematical phrase that contains one term or more than one term, and the terms are separated by addition or subtraction symbols. So, for example, 1.035s plus 1,000 is an expression with two terms. 5x plus 3y plus 7 is an expression with three terms. Remember that terms are separated by addition and subtraction signs. So something like 5x minus 3y is an expression with two terms, because subtraction can also separate it. An equation is a mathematical statement that two expressions are equal. The two expressions are known as the sides of the equation. So in this one, it has this side, the right side, as what we used for our expression, and then the left side is 1.05s. So the equal sign separates the two sides of the equation. Okay. It is helpful to think of an expression as a phrase and an equation as a complete sentence. Also, we simplify expressions and we solve equations. An example of a constant is the number pi, which is 3.14159, and it continues on forever. Its decimal expansion continues forever and never forms a pattern that repeats. We have a symbol pi to allow us to write the number exactly and succinctly. Even though the number pi is represented by a symbol, it's still considered a constant because it's an exact value and it doesn't change. Numerals like 4 function in the same way as the symbol pi does to symbolize a number. So it's a value that never changes. Okay, so understanding the difference between factors and terms is essential for the upcoming work we will do with algebra. One way to differentiate between factors and terms is to notice how variables and constants are connected to one another, and that's supposed to be the word are. So, when we look at the expression 3x minus 12y, we have, and I like how it breaks it down right here, 3x is one of the terms, 12y is the other term. Now, with this one, our constants are going to be 3, and 12 is another constant. So when we look at this, the constant 3 and the variable x are being multiplied. These multiply together, the 3 and the x. And that makes them factors of the term 3x. So both 3 and x are factors of this term. Same with the other one. 12 and y multiply to give you 12y, so both 12 and y are factors of that term. One thing to also point out is that number that leads it in the front is considered your coefficient. So your coefficient would be 3 and negative 12. So for this one, the expression 3x minus 12y can be written as 3x plus negative 12y. So we can think of the second term as either 12y or negative 12y. Objects that are separated by division are also considered factors, since any division calculation can be written as multiplication. So for instance, for this one, we can think of 15w over 4 as this. So our factors here would be 1/4, 15, and w. We won't normally have any that crazy though. All right, so here's example 1. It says identify all the components of the equation. So the first thing it wants us to do is look at expressions. Well, I want us to actually jump to B here, and if we look at this, we have an equation. The entire thing, the left and the right side, make up the entire equation. So our equation is the whole thing, 8x plus 1 equals 2x plus 6. So that is our equation. Now, our expression is going to be the sides of it. Because remember, an expression doesn't have an equal sign. So our expression, one of them would be negative 8x plus 1, and the other expression would be 2x plus 6. Okay, let's then look at our variables. So variables are just letters or symbols that represent different values. All right, so in this part we have x, and in this part we have x. Because the same variable shows up more than once, we only need to write it that one time. Okay, the next one are constants, so numbers that show up as part of the equation. So when I look at this, I'm going to look for just our simple numbers, so parts that aren't a variable. So we have negative 8, 1, 2, and 6. All right, the terms are things that are separated by an equal sign, so they are separated by addition, subtraction, or equal signs. So the first part that I have is negative 8x. The next term that I have is 1. And then we have an equal sign, and then I have the term 2x, and then the term 6. So all of those are terms because they're separated by addition, subtraction, or an equal sign. Okay, the next thing I have are factors. So if you have terms that have two parts, I'm actually even going to just break it up from here. Those are going to be your factors. So for that term, negative 8 and x would be our factors. And for this term, 2 and x would be our factors. I'm going to simplify it a little bit though, because x shows up more than once. So my factors are negative 8, x, and 2. And the last one that I have is coefficients. Coefficients are the numbers that are in front of a variable. So I'm going to look at whatever's in front of a variable. In front of this x, I have negative 8. So that's one of my coefficients. And then my other coefficient would be 2. For example 2, we're going to identify the terms and factors for each expression or equation. Okay, so my terms, remember, are separated by addition, subtraction, or an equal sign. So for the first one, the term is 5x. Factors are the things that multiply together. So 5 and x. For this one, my terms would be 5x, 8, and 0. 8 and 0 are just numbers. Nothing multiplies with them. So for this one, I only have 5x. That gives me factors. So still only 5 and x would be my factors. Okay, I'm not going to have us look at these two just because I've got some better examples coming up. All right. The next thing that we're going to be looking at is polynomials. So recall that exponents can be used to express repeated multiplication. So exponents are used for repeated multiplication. So for example, instead of writing 2 times 2 times 2 times 2, we can write 2 to the power of 4. So the factor 2 is repeated, or the factor being repeated is 2, and the number of factors that we do that is 4. So in this example, 2 is the base, which is the factor that's being repeated, and 4 is the exponent, which is the number of times that we repeat it. So when an expression has only a whole number exponent on the variables, just like this one, where we have negative 27x to the third plus 12.5x plus 5 over 4, so the exponents are just whole numbers. If you don't see one, it's invisibly 1. We call this expression a polynomial. Polynomials have no variables in the denominator and no variables under square roots. So you cannot have a letter or a variable in the bottom, so we can't do the following. We can't have a variable on the bottom of a fraction or inside the square root. We can't do either of those. So, a polynomial is an expression that has one or more terms that are constants or products of variables and constants. So really, they're just more than one. They're one or more terms. Any exponents on the variables must be written as whole numbers. There are some specific types of polynomials. If your polynomial has only one term, it's called a monomial. If it has two terms, it's a binomial. If it has three terms, it is a trinomial. If it is anything more than 3, we don't have a fancy name for it, and it will just be a polynomial. So nothing fancy for anything that's more than 3. Okay, our last real definition that we have, I know there's lots of definitions for today, is the degree of a polynomial in one variable is the highest exponent that appears on that variable in the polynomial. So it's whatever your highest exponent is. So in this one, the polynomial 4x squared plus 3x plus 5 has only one variable, which is x, and the highest exponent on x is 2. That is the largest exponent we see. So this one has a degree of 2. When an exponent on a variable is written, the degree is easy to determine. But what about when there isn't a variable? Or like when we don't see an actual exponent. For this one, in the case of negative 7x, there's only one factor of x. It's invisibly a 1 for your exponent, so this degree is 1. If you only have constants, so you only have numbers, there are 0 factors of a variable. So this is the same as like 14.5 is the same as 14.5x to the 0, because there are 0 of them. So this has a exponent of 0. All right, we're going to go ahead and practice some of these. In the expression, or we're going to see if the expression is a polynomial, we're going to identify it as a monomial, trinomial, or binomial, or none of those. And then we're going to identify its degree. If it is not a polynomial, we're going to state this and give a reason why. All right, so you'll save yourself some work if we first see if any of them are not polynomials. So remember, if it has a variable on the bottom of a fraction, it is not a polynomial. Or if it has a variable inside the square root, it is not a polynomial. So, and then one other one that I forgot to mention is that if you have an exponent that is, so if your exponent is not a whole number, so if your exponent is not a whole number. Okay, so I'm going to go ahead. This one, we don't have a variable inside a square root or under a fraction. This one is good. This one is good. No variable, but that's okay. This one is good. Now this one has an exponent that is not a whole number. So this is similar to what we deal with when we have a square root. So for this one, we don't have to go any further with this one. We can just say it is not a polynomial. And that's because the exponent is a decimal. Okay, this one is okay. It does have a fraction, but the fraction doesn't have the variable. So the x to the third is just multiplied with the fraction. This one's fine. Now when we get to h, the variable's in the denominator. So this one is also not a polynomial. And that is because the variable is in the denominator. Okay, for the other ones, you're going to go back and you're going to say, first, if it's a monomial, binomial, trinomial. All right, so for A, we are going to count the terms. Terms are separated by addition, subtraction, or an equal sign. Because these are just polynomials, though, we're only going to have it separated by addition or subtraction. So this has 2 terms, so this is a binomial. For B, this one has 3 terms, so it is a trinomial. For C, we only have 1 term, so it is a monomial. For D, this one has 1, 2, 3, 4 terms. So this one I'm just going to say polynomial because we don't have a special name for anything more than 3. For F, there is only 1 term, so it is a monomial. For G, 2 terms, so it is a binomial. Okay, the other thing that it asked us to do is to say the degree. So we're going to go with the largest exponent that it has. When I look at my exponents, I only have 1 exponent that's visible, and that's a 2. So the degree for this one is 2. For B, the largest exponent that I have is 2. So B also has a degree of 2. For C, we don't have an exponent, and actually for this one we don't even have a variable. So because there aren't any variables, we say that there are 0 variables, so 0 factors of a variable. And that one we had notes on the last page, so that has a degree of 0. For this one, the largest exponent that we have is 3, so the degree is 3. For F, we also have a degree of 3. And for G, the largest exponent is 4. Okay. Example 4 says, write an expression that has at least 3 terms. One of the terms should have more than 2 factors. All right, so if I want 3 terms, I want to separate those with addition or subtraction. And terms can be a constant, so just a number, a variable, or a combination of constant variable with multiplying or dividing. So let's say that I want to have 5x. So I've got 5 times x. This one, let's make sure that it has, one of the terms should have more than 2 factors. So let's try to have it have 3 factors. So maybe I want 3y, and then I want to have a third factor, so maybe I'm going to include another variable. So 3yz. This one has 3 factors. And then let's just have it be a whole number for the last one. So we have an expression, so doesn't have an equal sign. Good. It has 3 terms. Yes. And one of the terms has more than 2 factors. Yes. Okay. For B, write an equation that has at least 2 terms on each side. At least one of the terms should have a negative coefficient. All right, so let's just go with just 2 terms on each side. Maybe I want to do addition on both sides. It says that one of the terms should have a negative coefficient, so that means a negative number before a variable. So let's just start with that. Let's say I have negative 8x. Then maybe I want to have my next term be a variable. It doesn't always need a number with it. And then maybe I want 5z and then x again over here. So we have an equation because we have an equal sign. There are two terms on each side because they're separated by the addition. And one of the terms has a negative coefficient. Okay. Go ahead and turn the page. We're going to do just a few of these just to give you guys a little bit of practice on identifying the different parts. Okay, so for number 1, it says using 3x minus 7 equals negative 18. You're going to identify the different pieces. All right, so the expression is going to be whatever, if you have an equation, you're going to break it up between the left side and the right side. So the left side would be 3x minus 7, and the right side would be negative 18. Your equation would be the whole entire piece of it. So you would have 3x minus 7 equals negative 18. Your variables are any letters or symbols, so you would have your x. Constants would be your numbers. So 3, negative 7, and negative 18. I'm writing this one as negative 7 because I'm assigning it as negative because it was being subtracted. Okay, your terms are what are separated by addition, subtraction, or an equal sign. So we have 3x, negative 7, negative 18. Factors are any parts of a term that multiplied or were divided together. So for instance, 3x had two parts multiplied together, the 3 and the x. The other ones didn't have things multiplied to give us that. And the coefficients are what numbers are attached to a variable. So the 3 is attached to the x. So our coefficient would be 3. For number 2, it says identify each of the following as either an expression or an equation. Really simple way to do this. If it has an equal sign, it is an equation. If it doesn't have an equal sign, it is just an expression. So, I'm going to first identify the equations. B is an equation, and so is E. The rest of them are expressions. Okay. The last thing that I want us to do is looking at this one. Actually, you guys should be good, so because that was the same example that we had in our note packet, or on one of the previous pages. So you should be all set to finish up your questions on section 13.